Welcome grade 12s, because this video is for grade 12s only, on sigma notation. Alright, so sigma notation is just a notation we use to indicating the sum of terms in a sequence. Okay, so if you look at the sigma notation here, the sigma notation indicates the number of terms, in this case from term A to term B. Okay, and of course, because sigma notation is used to calculate the series, the sum, we are going to use our series formulae we learned when we did sequences and series. So we use our series formulas rather, from the sequences and series, and of course those are given in the formula sheet. Arithmetic, we have 2, geometric, 1, and if it's sum to infinity, it would be this one. So let's put this to application. Okay, so we are evaluating an arithmetic series, and of course the first thing we want to do is we want to get the at least the first two terms, term 1, and we also want to get term 2. All right, and of course we started 1, so to get term 1 we would take the part inside the brackets, and where there's an x we substitute 1. So of course, because we're starting with 1, term 1. So 5 times 1 is 5, and 5 minus 3 is 2. So term 1 is 2, and term 2 would be 5 times 2. It's actually 5 times 2 because it's term 2. Then you minus 3. 5 times 2 is 10, and 10 minus 3 is 7. Okay, so now we've got A. Remember, the first term is A, but we also can get D. What is the difference between the term D? Is 5. Okay, so this is what we need for our formula. Okay, and of course, if you wanted to use the second formula, then all you need to do is to calculate 10, the last term. All right, just for simplicity, I'll use the longer one. All right, we know we have 10 terms in this series. From 1 to 10 means we have 10 terms. So if you're substituting into this formula, it will be 10 divided by 2. No, that's 5. 2 multiplied by A. A is the first term, which is 2, plus n minus 1, that's of course 9, because there are 10 terms. 10 minus 1 is 9, and we have a difference of 5. Okay, we know that from the first two terms have a difference of 5, so all other terms will have a difference of 5. So if we just plug that into the calculator, all right, just for clarity, I will just okay, 10 over 2 is 5. Okay, and then 2 times 2 is 4, plus 9 times 5 is 45. Okay, but of course, to avoid errors, just punch it into the calculator as it is, and that will give you a sum of 245. So that's how you would evaluate an arithmetic series. Let's move on to 1.2. This time we are evaluating a geometric series. Here you need to be careful, because this particular series does not start at 1, it starts at 0. Okay, if a series starts at 0, then you need to calculate the 0 as a term 2. So from 0 to 6, so that would be 7 terms, right? Because you start counting from 0, not from 1. So from 0 to 6, you have the number of terms will be 7. All right, so let's get term 1 and term 2. Okay, so to calculate term 1, of course, we use the formula and we just substitute 0 where we start. Term 1 is 0 because we started 0. And of course, this is All right. So that means term 1 is 4. And this is, of course, A. Term 1 is A. So we've got A of 4. And term 2, we don't even need to calculate term 2 for this one because we already know that the part inside the bracket is R, okay? That is R ratio, a half. So R ratio is a half. So we know our A, the first term is 4, we know our ratio is a half, and we know we've got 7 terms, okay? So now we can evaluate the series. We plug it into the formula, the geometric series formula. There are 7 terms, so n we substitute with 7. And we know A, the first term, in this case is 4. 1 minus, the common ratio is a half. And of course, the number of terms again, n, we said we had 7 terms. At the bottom, we've got 1 minus the common ratio of a half. So if you go to your calculator to evaluate, okay, so we've got 4. Okay, let me just get the fraction first. Okay, so we've got 4, 1 minus the common ratio of a half to the power of, to the power of 7. Okay, and the denominator is 1. Subtract the common ratio of a half. Alright, so that is the sum we get of this series, 127 over 16. So 127 over 16. And of course, if we wanted to simplify that, it would simplify to 7,9375. All right, so that would be the sum of the geometric series there. Now, let's move on to the last question. And here we are evaluating the sum of an infinite series, okay? And of course, we need A. We need the term 1. And again, please note that here we're starting at 1, not at 0 like we did in 1.2. So to calculate the first term, we're going to substitute 1 because we started 1. So 1 minus 1 will give us 2.5 to the 0, which of course is just going to be 1. So our first term, A, is 2. All right, and of course, our common ratio, again, R is the part inside the bracket, which would be a half. So if you are evaluating the sum, this should be a sum to infinity. So if you are evaluating the sum to infinity, so A would be 2, the first term, term 1. Remember, term 1 is A, it's 2. 1 minus the common ratio of a half. And if you check, you evaluate that using your calculator. And of course, we've got 2, 1 minus a half. And of course, the sum of all the terms in that series would be 4. All right, so this is the end of this lesson, grade 12s. Please like and subscribe to this video if you haven't done so already.